All right, this video will show you how easy it is to use a chi-squared goodness of fit test using StatCrunch. So once you've grabbed your data for observed and expected and copied that and then pasted it to StatCrunch that needs to be open, in order to perform this chi-squared goodness of fit test, you just look under the stat menu and you'll see it says goodness of fit. And you just slide over to chi-squared, click on that, and then the observed data was in column 1, in var 1, and the expected value was in column var 2 after I pasted them. And after you select those, you just simply push compute, and there are your results. It shows the chi-squared value, your degrees of freedom, and your p-value. It doesn't show the chi-squared critical value that this chi-squared test value is compared to, but the p-value it would obviously be more than alpha, and thus we do not reject the null hypothesis. Let's do it for the other set of data that we did, that we used in this section. So I'm just clearing out the data and then grabbing this tab where the data for observed and expected. This was for not the flat tire and missing class example, but the Super Bowl betting pools last digit. So these are the observed values of winning after a quarter. A 0 at the end of one of someone's score happens a lot. You can see 113 times, as does a 7, because of the combinations of field goals at 3 points and touchdowns, normally with point after, which are 7 points. So I'm going to copy that and go into StatCrunch and paste those values, and just once again go in the stat menu, go to goodness of fit, chi-squared test, and again the observed data is in var 1 and the expected is in var 2, and I compute. And again, here we can see now the p-value is a lot less than a normal alpha value of 0.05. That's a really great chi-squared test value, which I'm sure would exceed the chi-squared critical value for the degrees of freedom of 9. And now that means that we're in the tail. So we definitely reject the null hypothesis in this instance.